Hello my students, hello everyone. Here we go for section 2, which is balancing the redox equations. We have to explain what must be conserved in the redox equations, balancing the redox equations by using the half reaction method. For balancing, we have to write the formula equation if it's not given in the problem, then write the ionic equation. Also, we have to assign oxidation numbers, delete substances and containing only elements that do not change the oxidation state. Number 3, write the half reaction, balancing atoms, balancing charges, and also write half reaction for reduction, balancing atoms, balancing charges. Number 5, conserve charge by adjusting the coefficients in front of the electrons so that the number lost in the equation equals the number gained in the reduction. Combine the half reactions and cancel out anything common to both sides of the equation. Combine ions to form compounds shown in the original formula equation and check to ensure that all other ions balance as shown in front of you. Here we go for a sample problem. A deep purple solution of potassium permanganate KMnO4 as the following: KMnO4 is titrated with a colorless solution of iron 2 sulfate FeSO4 and sulfuric acid H2SO4. The products are iron 3 sulfate Fe2SO4 all by 3 and magnesium sulfate, potassium sulfate, and water, all of which are colorless. Write the balanced equation for this reaction first of all. The KMnO4 reacts with the FeSO4 and the H2SO4 resulting as shown: Fe2SO4 by 3, MnSO4, K2SO4, H2O. Okay, for more clarification, write it separately. Here, the potassium was positive 1. Therefore, the MnO4 is negative 1, of course. Here, iron is positive 2. The SO4 is negative 2. Okay. The hydrogen, 2 hydrogens, each of them is positive 1 as shown in the previous video. The SO4 is negative 2. Now let's come to an answer. In the next step, the Fe is positive 3 as it donates with 3 sulfuric ions, and the sulfuric ions remains negative 2 unchanged. The manganese positive 2, the SO4 as shown, the potassium as shown, and the SO4 negative 2 as it is, and the water. Okay, the next one. Assigning the oxidation numbers as shown for each of them by calculating. The potassium is positive 1, the iron, all the elemental forms is mentioned right here, or okay, the manganese and oxygen, of course oxygen is negative 2, and I can calculate the manganese to be plus 7. The sulfur is plus 6, and so on. Therefore, the iron here plus 2, it means that it lost 2 electrons, and here it lost 3 electrons. Therefore, it is being oxidized because iron plus 2 gives iron plus 3 plus electron. While the manganese, it turns from positive 7 into positive 2. Balancing the mass indicates that the manganese oxide plus hydrogen gives manganese plus water. Therefore, the manganese gained electrons as it transformed from positive 7 into positive 2. adjusting the ratio. The loss in the oxidation is 1 and the gain in the reduction is 1. Therefore, the 5 iron ions takes reaction with the manganese oxide. Then iron gives iron plus electron, but of course all of them times 5. 5 iron, 5 iron, 5 electrons. Then the manganese plus 8 hydrogen plus 5 electrons gives the manganese plus 4 water. I can sum this plus this times 5 plus this gives Mn positive 2 plus iron times 5, of course, plus 4 plus electrons, which eliminates together to give the final equation. 5 Fe as shown, 5 Fe plus MnO4 plus 8 hydrogen gives 5 Fe plus 3 plus Mn2 plus 4. Combining with the original equation, then we can multiply by 2 in the original equation to get 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 gives 5 Fe2SO4 by 3, 2 MnSO4, K2SO4, and 8 of water molecules as shown in the original reaction here. That was all for section 2, balancing the redox equations. Stay safe and study hard, checking your LMS. Bye bye.